Okay, you should be able to find these notes either linked in Google Classroom or you might have a paper copy of them. The warm-up part 1 is just graphing a cosine equation, and I do want you to try to give that a go as a practice refresher. And then part 2 is solving a trig equation with technology, which we practiced last class in your calculator. And we will look at those next time I see you in person. But today we're going to actually solve algebraically. And so I'm going to do these first 3 with you, and I'm not going to do them ABC. I'm actually going to go ACB. And then we'll look at another example or 2 after that, and you'll kind of have an idea of what to do algebraically. So I'm going to do A first because A kind of sets us up. First, notice that they're all 3 of these are sine equations, and they're all equal to -1/2. I did that on purpose so that the actual outcome values are the same before I have to apply algebra. Also notice that moving from A, B, and C, what's happening is there's some operation being applied to x inside of the parentheses. I know there's not parentheses here, but there's sort of an implied parentheses there. And that's different than if there's stuff on the outside of the sine function. You still have to do algebra both ways, it's just the timing of the algebra. So when it's inside the parentheses or being applied to x, you have to do it after you've already found your possible solutions. So part A is basically going way back to the unit circle. We've already done these problems, we just didn't do it with an equal sign. Or maybe we even did do it with an equal sign, or your question was, when is sine equal to -1/2? So when is the y coordinate -1/2 on the unit circle? So you may have to think a little bit about that. First off, sine is negative. If we go to the all students take calculus, sine is negative in quadrants 3 and 4, so I know my answer's down there. Again, I'm looking for all the answers between 0 and 3 pi. That's going to be an important piece of this. That's going to come into play a little bit more later, not so much on this first example, and I'll tell you why that is in a minute. And again, -1/2 is the y coordinate, so that means I have a little, again, these are on the unit circle, so they have to be either 45, 45, 90 or a 30, 60, 90 triangle. And so the -1/2 is y, so that's like your little short side, and it would be one of these two. And the little short guy, the short one in height-wise, is always a pi over 6. So you just have to figure out which value of pi over 6 that would be. This one is right after halfway point of pi, so it's a pi over 6 past a half. And so that would be, so again, if this is pi, you're halfway around a full revolution. This is 1 pi beyond that. So that would be 7 pi over 6. 1 pi over 6 beyond a full pi. And then if we come here, you're pi over 6 before getting back to 2 pi, so you're not quite to 2 pi, so you're a pi over 6 shy, so you'd be 11 pi over 6. And then and that's, again, if I'm talking about those 2 answers, that's in my first revolution of going from 0 to 2 pi. I need to go all the way to 3 pi, so I would have to actually check answers on another half of a cycle. But notice that there are no more answers up top because I'm asking when sine is negative and sine is positive up there. So those are my only 2 answers. And again, I use those because I'm gonna build off of those for these 2 problems. So again, if it's inside of your sine equation, if it's in the parentheses happening to x, your first question really is, when is sine equal to -1/2? So I already have those 2 answers. They're right here. So the first part of this problem would be accessing the same idea we did here. I'm going to ignore this stuff on the inside to begin with, and I'm just going to answer these 2 questions. So it means it happens at 7 pi over 6, but it also happens at 11 pi over 6. But I'm not asking about when is sine of x equal to that. I want to know when is sine of x minus pi over 6 equal to that. So this stuff in the parentheses is now set equal to my answer, and I have a little algebra step. So in this case, my algebra step would be adding a pi over 6 to both sides. So I would add pi over 6, just like solving a regular algebra equation, and I would add pi over 6. those would cancel, and I would have one answer, which would be 8 pi over 6, and I'll simplify that in a minute. And if I add pi over 6 here, those would cancel, and I would add pi over 6 here, and I would have 12 pi over 6. Again, I will simplify in a minute. And those are my two answers, going off of the original two. But again, I'm looking for everything between 0 and 3 pi. And remember, if you think back, these answers repeat every 2 pi. So I have to really think about, okay, if I added another 2 pi to this, would I still be in this particular bound that I'm looking for? Or if I subtracted 2 pi, would I be in this bound? So since these answers here are in sixths, I'm just going to, before I reduce it, think about what 3 pi is in terms of a sixth. And so this upper bound, if I put a 6 on the bottom, would be the same as 18 pi over 6. And then if I added 2 pi, because the period again is 2 pi, there's no period shift here. So this answer is going to repeat again. I'm going to get, if I add 2 pi, I get the same output. So if I add 2 pi, again, 2 pi in terms of sixths is 12 pi over 6. That's 2 pi. If I add that to 8 pi over 6, I would get 20 pi over 6, and that's too big. If I subtract it, I would have a negative answer, and I want to be bounded by 0. So that means this answer is good to go. If I do the same thing down here, if I think about adding or subtracting a 12 pi over 6, I'm looking at going 2 pi in either direction. Obviously, if I add 12 pi to 12 pi, I'm going to get 24 pi over 6, way beyond this. And if I subtract it, I'm actually at 0. And if there had been a little equal sign under here, I would have to count that answer, but there isn't. So I'm actually done. These are my two answers. So this process didn't find me any extra answers, but it's an important one because we're going to do it later. So my two answers end up being this one, which is 4 pi over 3, and this, which is 2 pi. So those are my two answers for this problem. And they're different than this because I had to phase shift to the right, and so I'm going to go to the right to pick up different answers. Again, this is the thing about that graph moving to the right. All right, so this one, again, similar. I've got it equals sine of some function equals -1/2. Notice the sine function and the 2 is in with the x, so I basically set this equal to when sine is equal to -1/2, which I already spent the time to do. Same down here, 11 pi over 6, and I'm going to show you a couple ways to approach this. And now, again, just like I did a second ago, I have to now set this expression inside the sine function equal to that, and then I need to solve it. So to get x by itself here, I need to divide by 2, or since I have a fraction over here, I'm just going to conveniently multiply by half. Same thing, and it's just easier for me on the other side to multiply by half than divide by 2. And I get an answer of x equals 7 pi over 12. Again, these cancel, this cancels. I get an answer x equals 11 pi over 12. But now I have to think about the fact that these answers again repeat every period. Like the sine will equal this every time I move another period. But because this 2 is in here, that's an adjustment to the period. So the period is no longer 2 pi. So this answer doesn't repeat every 2 pi. And if you remember, this 2 is going to change my period by doing 2 pi divided by b. And so 2 pi divided by 2 is pi. So my new period is pi. So this is actually going to change answers every pi now. Same down here, plus or minus pi. So you've got to think about what that does to your period to know how your answers are going to come. And since these are in twelfths, I'm going to change this to 12 now. So again, my top bound is 3 pi, which is 36 pi over 12. That equals 3 pi. So this is my goal. I can't go beyond this, and I can't go beyond 0. So again, that's why I put plus or minus. So down here, because these are in twelfths, I'm going to write this as 12 pi over 12, just so I can have a common denominator. Again, this is why these are a little bit more challenging, is you are going to have to deal with fractions. There's no way around it. And again, I'm going to just quickly look at subtracting. Will get me a negative in both cases, so I'm not going to worry about the subtracting piece. But if I add 7 and 12, I get 19 pi over 12. And that's in my bound. And if I add another 12 pi to this, I get 31 pi over 12. Also still captured, but if I add another 12, I'm too big. So the 7 pi over 12, and if I add pi, I get a couple more. Here I have 11 pi over 12. And if I add 12 pi over 12, I get 23 pi over 12. That's still in here. And if I add another 12 pi over 12, I get 35 pi over 12, which is captured just inside my bound. So this part B has 6 answers. And again, remember, that is going to make your period compress a little bit. So when I go to find the answers, I'm going to have more of them than if my period were a little bit longer. That's why I have more answers. So the second way to kind of approach that, if you want to, is I'm going to come down here and I'm going to erase this piece. And I think I'm just going to do it for the first one. Actually, I'll go erase all of this. So another way to think about it in general terms is, as you go to write these answers, you know this is that sine equals negative 1/2 at 7 pi over 6 plus every 2 pi. And so you could write 2 pi k, where k is an integer, like positive or negative numbers, meaning that takes care of that plus or minus piece, and it indicates that this is going to repeat forever. Same down here, plus 2 pi k. Now the reason that can help you if you do that right off the beginning is the initial period is always 2 pi for sine and cosine, and then whatever this adjustment is, as I apply it algebraically, I can come down here and do the same thing. I can go times 1/2, which means if I multiply the left by 1/2, I have to multiply everything on the right by 1/2. So this gets multiplied by 1/2, as does this. And again, I'm just going to erase a little bit down here so we don't get our two problems confused. And if I do the same thing right here by 1/2, and I have to multiply this by 1/2 and then this by 1/2, again, I get x equals 7 pi over 12 plus 1/2 times 2 pi k is pi k. So you get that period shift automatically from doing this algebra step instead of having to go back and think about how this impacts your period. But remember, the only time your period is going to be impacted is if there is a multiplier or divider by x. Like, there's no period adjustment here, so I know that's just every 2 pi. Whatever I get for an answer, I can add or subtract 2 pi. So that's the only case you would have to think about your period adjustment. And you can either do it after you get your answer, or you can do it immediately and let algebra get your answer for you. So I'm going to end this video now. We're not going to worry about this one. We'll look at this one in class next. But I do want to move to the second page, and we'll look at these two in class. It's the same idea, just with cosine, same exact idea. I'll kind of briefly touch on those two things, but then I'll come down and I'll look at these two in the next video, which should hopefully be a little bit shorter.